Hello children, today we will discuss chapter number 11 from our science textbook. The name of the chapter is Light, Shadow and Reflection. We will discuss about light, its properties, shadow, pinhole camera and a brief introduction about mirrors and reflection. So let's get started. We see a lot of things around us every day, like the buses, cars, tables, chairs, trees. Now, there is one thing that enables us to see these things. This is light. If there were no light, we are not able to see anything. So, this brings us to the next topic, that the sources of light. What are the sources of light? We have two types of sources of light. These are natural sources and man-made sources. Natural sources means the sources which are already present in nature, sun, stars, glowworms, etc. And in man-made sources, we have candles, earthen lamps, gas lamps, electric bulbs, and so on. Now, these objects which are present around us, they are categorized into two categories, luminous and non-luminous objects, on the basis of the property of emitting light. So, if an object can emit light or if an object possesses the light of their own, they are called the luminous objects. In this category, we can fit in both the natural and the man-made sources of light like sun, stars, candles, and electric bulbs. The non-luminous objects, these are the objects, they do not give out light of their own. It means they do not emit the light of their own, like the chair, table, trees, etc. Then we have transparent, translucent and opaque objects. Now, how are we going to differentiate between these three categories? The simple phenomenon being whether the objects allow the light to pass through them or not. There are some materials or the objects which allow the light to pass through them completely. These are called the transparent objects. The example, glass tumbler, glass window, etc. The objects which allow the light to pass through it, but not completely, only partially. These are called translucent objects. The example being butter paper, tracing paper, oily patch on paper, or frosted glass. Then again, we have a category of the materials which does not allow the light to pass through it. These are called the opaque objects. Now the opaque objects, these are important here. Why? Because the opaque objects are the only ones which forms the shadow. A shadow is formed when the light passes through an opaque object. Here we can see a picture of a girl and the shadow as well. So for the formation of a shadow, the things that we require is number 1, source of light, number 2, opaque object which will obstruct the path of light, and number 3, an opaque screen on which the shadow will be observed or shadow will be seen. Now the shadow which is seen, it does not have any color. Suppose I am wearing a red colored dress and my shadow in that shadow of mine, that red color will not be visible. The shadow is always black in color. It can give an outline of the object, but the shadow can be misleading as well. And we have seen that in this image you can see throughout the different time of the day, we can see the shadow shape keep on changing. Now, how this happens? This is based on a phenomenon or a simple concept that a shadow, it is always formed in the opposite direction of the source of light. We will understand it with the help of an example. During morning or morning time, what happens? The sun always rises in the east. Okay, now the source of light is in east direction, so the shadow will be formed towards the west. In the evening, the sun is towards the west. Now the shadow will be formed toward the east. And at noon or 12 p.m. in the afternoon, what happens? The sun is right above our head. So at this point of time, the shadow will be formed right below us. So now we know that the different shapes of the shadows is because of the difference in the position of the source of light during the day or throughout the day. Now next here is our pinhole camera. Now what is a pinhole camera? Pinhole camera, it is a simple application of rectilinear propagation of light. Now what is rectilinear propagation of light? The light, it always travels in a straight line. And because it travels in a straight line, so the name is being given to it is rectilinear propagation. Now how we are going to construct a pinhole camera? It's very easy. What we have to do is we have to take two cardboards. Now one cardboard should be slightly larger than the other. Okay. So what we have to do, the first step being, we'll cut one end of both the cardboards. Now in the larger box, we will make one pinhole or a small minute hole. And in the another cardboard, we will cut a square portion of that cardboard and we will remove it. Now after we have removed that square patch, in the place of that, we are going to paste a tracing paper. Now we will slide the smaller box in the larger box. Now our pinhole camera is ready. Now what are the different observations we are going to get from the pinhole camera? Whenever we see any object through the help of pinhole camera, what happens? The size of the image is always diminished or smaller in size. And the image which is formed in the camera, it is always inverted. Inverted means upside down. The uses: a pinhole camera, it is used to measure the height of objects like a building or a tree. It can be used to take the image of the sun. And during eclipse, the change in the shape of the sun, it can be easily studied through a pinhole camera. Now here is an interesting phenomena is there, that a natural pinhole camera is also there. Now where it is? Yeah, it is present everywhere around us. So you must have seen any tree which is covered with innumerous leaves, or many, the number of leaves is huge in that tree. So what happens? Under the tree, you must have seen some square, oval shaped or spherical shaped patches of light. Now what are these? These are the images of sun. And these are formed by the gaps between the leaves of the tree. So here the gaps the gaps between the leaves of the tree, they act as pinhole camera. Next one is mirrors and reflections. So before starting this topic, there is one interesting thing to notice. We have already discussed, or we have already seen, that the light, it always moves in a straight line. So is it possible that somehow the light can move in another directions as well, not in a straight line? So it will be possible only when a light will pass through a polished surface and it will bounce back. And this phenomenon is known as reflection. So reflection is being carried here with the help of a plain polished surface, which is known as mirror. Whenever the light, it falls on any object, only three situations can happen. It can pass through the object, means we can see in the case of transparent objects, or the object can absorb it, or the third category is the light passes on the object and it gets bounced back. So the passing of the light and then getting bounced back, that is known as reflection of light. Now for the reflection of light, what do we require? We require a polished and shining surface. So on these surfaces, the maximum reflection is observed. Here you can see the image. In this image, you can clearly understand the concept of reflection. There is one boy, he is just lighting a torch, and then there is a mirror. Then the light passes through the mirror and then bounces back in another direction. So here we have seen that the light can move in another direction also. But it is possible only when it collides or when it strikes through a surface and then bounce back, which is known as reflection. That's all for the day, children. Thank you so much. Have a very good day ahead.